For the first time, NASA's Hubble Space Telescope has spotted what appears to be an isolated black hole racing around the Milky Way galaxy like a cannonball. Astronomers think it is around 5,000 light-years away and traveling at speeds ranging from 67,000 to 100,000 miles per hour. Hello there, and welcome back to the Discover Space channel, where we explore cosmic possibilities that you'd really want to know. Be sure to subscribe if you haven't already, and let's get on to the video. Right now, you are looking at stars orbiting the supermassive black hole at the center of our galaxy. All these S-stars offer the first indications of the gigantic object at the center of the Milky Way is, in fact, a black hole. Because even light cannot escape the gravitational pull of a black hole, astronomers must rely on indirect methods to demonstrate their existence. As a result, we can only find stellar mass black holes in binary systems by analyzing gravitational wave signals or electromagnetic radiation released by the system's companion stars. However, astronomers believe that we have yet to locate an isolated free-floating black hole in the Milky Way. But after 6 years of diligent studies, NASA's Hubble Space Telescope has produced direct proof for a lone black hole floating through interstellar space for the first time ever by a precise mass measurement of the phantom object. So how did Hubble make such a thrilling discovery? Most importantly, why is this so significant in physics and astronomy? Stellar mass black holes arise when a massive star, well over 20 times the mass of the Sun, falls under its own gravity toward the conclusion of its life. Since the self-detonation is not precisely symmetrical, the black hole may receive a kick through our galaxy like a cannonball. Although we cannot directly view the free-floating black hole, we can determine its presence indirectly. A black hole warps space, scattering and intensifying sunlight from whatever that happens to be exactly behind it at the time. Gravitational microlensing is a phenomenon hypothesized by Albert Einstein in 1936 using his general theory of relativity. It is mostly used to detect exoplanets, with over 30,000 microlensing events documented in the Milky Way thus far. When a huge object passes in the foreground, ground-based and space telescope that monitor the brightness of millions of stars in our Milky Way's rich star fields seek for a rapid spike in brightness. And one of the best tools for the job is the Hubble Space Telescope. This microlensing event was initially spotted by astronomers in August 2011. As the black hole passed by, the star flared and afterwards dimmed back to its usual brilliance. But how do we know the foreground object was a black hole rather than a compact rogue star? There are two key considerations. The first is that the black hole's tremendous gravity considerably extends the microlensing duration. This microlensing event, for example, lasted approximately 270 days. Second, if the passing object were a compact star, it would create a temporary color change in the measured starlight because the light from the foreground and background stars would be mixed for a brief instant. However, no color shift was observed during the black hole occurrence. Hubble also calculated the amount of deflection in the background star's image caused by the black hole. The star's picture was roughly a milli-arc-second off from where it should have been. This astrometric microlensing approach revealed the mass, distance, and velocity of the black hole. Two teams evaluated Hubble data, one from the University of California, Berkeley, and the other from the Space Telescope Science Institute of Baltimore. and both discovered a compact object. According to NASA, the Baltimore team assessed the object's mass to be 7 solar masses. 1 solar mass would equal the weight of our Sun. The Berkeley team's findings, which ranged from 1.6 to 4.4 solar masses, were more unclear, possibly pointing to the discovery of a neutron star instead. The observations were complicated by the presence of a reasonably bright star near the lensed star. It was like observing the tiny movements of a firefly beside a bright bulb, according to the team. To correctly quantify the deflection of the dim source, they had to remove the light from a neighboring bright star. The black hole is moving across the galaxy at 100,000 miles per hour, which is equivalent to 160,000 kilometers per hour. That is faster than the majority of the other stars in that region of our galaxy. It is located approximately 5,000 light years away in our galaxy's Carina-Sagittarius spiral arm. The findings have also enabled scientists to calculate that the closest isolated stellar mass black hole to Earth could be as close as 80 light years distant. This is roughly 20 times the distance between the Sun and its closest star neighbor, Proxima Centauri. While locating these rogue black holes may reveal new insights about the population of these strange objects in our galaxy, it will be like finding a needle in a haystack. Astronomers assume that solitary black holes create only one in every few hundred microlensing occurrences. However, NASA's planned Nancy Grace Roman Space Telescope will uncover thousands of microlensing events, many of which will be black holes. Moreover, the deflections will be monitored with extreme precision. The Roman Space Telescope is an infrared telescope in development that is set to launch no later than May 2027. Some spectacular astronomical discoveries are undoubtedly on the road. That's it for this video. Thank you so much for tuning in with us for another cosmic adventure. Please let us know down the comments below what other cosmic adventures you want to take on next. And we'll be with you then.